Hey everyone, welcome to the launch of SST testing. It is less of a launch, but it's more like uh, it's like a walkthrough of what are the ways you can test your SST apps and how many ways you can test it, the different type of test. And so we're going to go over that today. Let's just jump right into it. And oh, by the way, we recently launched the SST load config command, and we'll also be showing that how we're using that command to facilitate some of the testing, how that makes the testing easier. Cool. All right, let's jump right into this. Let me bring up my screen. Cool. All right, to make it easy to follow along, I'm going to use the GraphQL stack. I'm going to create a new app from based off the GraphQL stack, and we're going to be looking at how to add tests to it, how to add tests for it. If you want to follow along, you could run npx create SST add latest. When this command runs, let me just make it bigger. When the command runs, select GraphQL. Yeah. When the command runs, select GraphQL and select DynamoDB and give it an app name and let it create a project. So on the left here, I already have a project that's created. I think I'll adjust the size. It mess some things up. All right. Let's open up the app that we just created. If you're familiar with the GraphQL stack, if you open up the index, it's a really simple app. It deploys a database, an API, and a web. And the end deployed version, which I deployed right before this the stream, is you can see what the deployed version looks like. Oh. It's really a very simple a Reddit clone where you can just submit a title, say, hey everyone, and let's give it ST. It's like really simple Reddit clone, and if you refresh, data are persisted. And what's going on behind the scene is that we are creating a database, an API, and a web. 3 stacks. If you go into the database, really simple. It's just got one DynamoDB table. And the reason it's creating a DynamoDB table is because when we bootstrap the app, we selected DynamoDB right here. Right? You could select RDS, or you could use any other template you want. For today's the tests that we're going to show is not strictly related to GraphQL. It works for RESTful endpoints, RESTful APIs. Even works if you don't even have an API in your app. Cool. And the API endpoint is really simple. API gateway, HTTP API, and the web is React, is v static site. Right. Again, very simple. Each stack pretty much just have one construct in them. Cool. So you kind of have a feeling of what our app looks like. Let's start doing tests. Today, I want to go over 3 types of tests. If you look at the first type we're going to go over, is really testing your domain functions. And if you're curious what domain functions are, you could take a look at the domain design video by Dax. And he talked about how you're supposed to structure your application into these your handlers, almost like outward-facing handlers, and the core of business logic are put inside these domain-specific function modules. And if you look at the folder structure, right, we have the stacks, which contain all the infrastructure code, and we have services. And inside services, it has a core, it has functions. Inside the functions, you can see it has this GraphQL.ts, which is the entry point for our GraphQL endpoint. So when this API gets invoked, it's going to call this GraphQL handler, and eventually everything will get sent to this article domain that inside our core folder, and this function pretty much has a create function, a list function inside articles, which are really responsible for what we want the right on the front end. Right? When you hit submit, eventually the request is going to get into create, and when you load this page, you're pretty much calling a list. Cool. So we really have two important functions in our app: a create and a list. And so we are going to look at how to write some tests to test these two core functions. Cool. We will. Let's get to it. So inside the test folder, so inside our services, you could structure a test however you want. I like to put them inside services, put a test folder in there. If you clone the template, you should already have a test. We'll go over that in a second. But in our case, I will just create a core folder since it's testing our core functions. And in there, since we're testing the article domain, we are going to create a file in here called article.test.ts. Okay, let's do some live coding. So for this test, we are oh, by the way, if you created your application using create SST, it comes with a v-test config that's set up for you already. So you don't have to configure anything else, but you're free to use any other test frameworks like Jest or anything. We prefer v. It's super fast. All right, let's create a test. We'll call it create. What are we doing? Create an article, right? Let's call it create an article. Look at Copilot go. All right. That's not right. Mine sometimes. So we are going to call await article dot create. We're going to pass in the title. Let's call it test of August 25th. So this is live. We're not looking at stale data, and we're going to pass it. Right, we're going to submit a URL. Let's give it. Yeah, let's call it two sentences dev again. Cool. So we're calling this function, and this function is going to return us an article. Cool. And so how are we going to test? Let's do a list. On the list function, that's going to give us all the articles in the system, and let's run expect of. Let's see if the function that we just created, right, is being returned in the list. And it's missing some imports. This, and we need to import article. Let's just remove the default test it came with. Let's rename this so we only have one test when we run, one result when we run a test. Cool. All right, let's run npm test. That's what do we get? Cool. Our test passed. Let's quickly look at what is the npm test script that we have in here. If you just open up the package.json in our root folder, you can see a test command has been configured to run SST load config -v test run. What we're doing here is SST load config is pulling in, all the parameters or secrets that you're using in your app, because those values are there in the Lambda environment. If you look at the deployed Lambda function, let's take a look at what config we're using. To run this test, it's talking to the database, right? Somehow you need to know which database to talk to. If you look at our core logic for the article, it's calling this function inside DynamoDB. And DynamoDB somewhere is calling config.tablename, right? Where does config.tablename come from? It's actually a parameter that we set up in our database stack. So after we created this database, we create this config called config.parameter, and this config is called table name with the value of the name of the table. And in our API stack, we are passing the table name into the functions inside the responsible for the GraphQL handler, right? So if you look at what's going on when you deploy to AWS, so when it runs, SST sets these 3 environment variables called SST app, SST stage, and SST param table name. So for each parameter, you're going to have one environment variable with this table name in there. If you're not familiar with how these are set up, you can go watch the video from last week. We went over how the config construct is creating and managing secret parameters. In this case, so when your function runs inside the inside Lambda, the table name is coming from the environment variables. But when you're running the test, how does our test know what the name of the table is, right? Because it's not running inside Lambda environment. So this is what the config. This is what SST load config does. It pretty much sets up environment variables so that it kind of mocks what the environment you have when you run inside Lambda, when you're running inside Lambda, and set them as environment variables. So and then when you run v-test, when your code gets to config.tablename, it knows what the table names are. If you were to run npx v, if you change or test, say we remove SST load config, see what happens. Right, it's saying cannot find SST app environment variables. Even if you manually add SST app, it's going to complain SST stage is not found, table name is not found. Right, this is pretty much what the SST load config does. We will go over what is going on behind the scene in a little bit, but for now, you just know SST load config is this magic command that pulls in all the environment variables so your test can run. And your code can run as if they're running inside the Lambda environment. Cool. And another thing I want to mention is note that our test is just calling our domain function. We're calling it create. We're calling list. Our test is not aware that we are using DynamoDB, or we're using Postgres. When we created, when we bootstrapped our app, you could have select Postgres instead of DynamoDB, and this exact same test would still run, right? Right, because we're not testing making calls to the underlying database. We're testing at like a very high level, which is very recommended, right? You don't want to test something. You don't want to test like implementation details. You want to test just at a high level your domain function works as expected. Cool. That is an example of how do you test, your core domain functions. Let's see. Let's write another type of test. The second type of test we want to run is, we have an API. Let's take an outer scope and let's test on the API. So like someone just mentioned that you don't want to test implementation details. When you're testing your domain functions, you're still testing something within your app. When you test your APIs, it's really the behavior is very similar to a request that the front end user is making from your website. So you kind of want to test. You want to run the type of test that's as close to a real life situation as possible. Cool. So we're gonna write a test. Actually, that's a test. That test is what this template already come with. So if I just move that test back, you could see that this test is very much similar. Let me just put them side by side. It's very similar to the domain test we wrote. So in the domain test, instead of calling article.create, we are actually calling, we are creating a GraphQL client, just like how you create it on the front end. And we're making a mutation call to, to the GraphQL client. Again, if you're using, RESTful API, hey, this is nothing GraphQL specific. You can just call your CRUD API to create an article, and you pass in some title and URL. So entire this part from here to here, you're creating an article, right? That's the same thing as you were doing before. You're creating an article, and everything comes after. You're listing all articles. On the right side, same thing. You're listing all the articles, and your tests are, in this case, surprisingly similar, right? The only thing we change is we're not calling your domain function. We are calling from outward facing API endpoint. Only thing that's kind of different here is you're matching against what the API returns versus what your domain function returns. Again, very similar. Cool. Let's run our test again. Now we have two tests. You just hopefully see two passed. Cool. All right, two passed. It's very smooth. Okay, if you're paying attention, right, you're gonna notice that we are using config.api URL, right? So when you're making API test, how do you know the name of the API, right? You don't want to deploy first, know the endpoint, and then update your test to hardcode endpoint in there, right? So in this case, we're piggybacking on our config parameter. So if you look at our API stack, after we created API, we created this parameter with the name API underscore URL, and the value is the endpoint of our API. Again, who's doing the trick? It's our load config friend, right? He's doing the trick of, when you're running the test, it's pulling the parameter from, from your your environment, your SSM, and it's making them available for V-test that's running after it. That's why config.api URL is able to figure out the endpoint of the test, sorry, of your API. All right, cool. So this is the second type of the test we just run, which is the API test. Again, personally, I like running I like writing API tests as much as I could. that just gives me, a peace of mind of, you know, I'm sure that when user click this button to when user click the submit button to to create an article, that use case is being tested, right? Why just test? Why just test the domain, my domain function? It's that still doesn't cover everything. This API test actually go through API gateway, all the way through. So not in the test, but in the test, it would actually go through. No, wait, no. Yeah, in this test, actually go through all the GraphQL handler code. So it's very similar to a real life situation. Cool. All right, let's look at the third type of tests we have. The third type of test is testing your stack code. Everything we test so far are testing your business logic, but there are things that are worth testing that is not within your business logic code, right? For example, things like, in this case I'm using DynamoDB. Is my DynamoDB backup enabled? DynamoDB has this feature called point in time recovery, right? So when our database is corrupted or is down, you want to um, roll back to a point in time. I think within the last 35 days, you could, if you have this feature enabled. And I think you get charged per gigabytes of data. So and usually you don't have that much data for your testing environment. So usually it's something I kind of recommend always keep it on, right? So it's worth testing that does your database have the backup turned on, and or if you have functions that are doing some intense computing, right? You want to make sure that when I deploy my function, they are using at least 1 GB of memory. Right? There shouldn't be any. You shouldn't make like a change inside. Function default. You say, oh, you override it by mistake that your function now only have 128 megabytes of memory, right? You can write a test to make sure when they deploy, they always have 1 GB of memory. Another test that's really worth writing is for your very sensitive data storage resources like S3 bucket or DynamoDB table or RDS cluster. It's very important that you don't change the IDs. If I were to show you an example, it's very important that you don't change this ID, because when you change this ID, that changes in CloudFormation, that we call it like logical resource ID. When the logical resource ID changes, CloudFormation will think, oh, this is a different resource. So you remove your old resource and you're going to add this new resource. So CloudFormation could wipe out your data, your table, and create a new table for you. Of course, right? You could enable data retention on this, so that this table doesn't get removed. You just get removed from a CloudFormation template, but the table is still there, right? You could still manually look up the data, right? That's another thing worth checking, right? Do you have retain turned on for this table? And right, is the table name changed? Sometimes you're not even paying attention, right? This table, this table, you didn't change the name, but if you create another, you move the table inside that construct, behind the scene is really tricky. It's logical ID is like changed in that case, right? Because what logical ID, how CK creates these logical IDs is, you look at construct hierarchy, and they concatenate out all the names between this table name, the construct, this table name sits inside, and then the stack is sitting inside, and the app that is sitting inside, right? You look at this entire hierarchy to build up this the logical ID. And if you move this table around, you could change the logical ID even without changing the ID of the table. So there are these type of tests that are really like infrastructure tests that are worth testing. So you don't get surprised when this table get dropped, or your when you do the backup, you'll be like, oh no, my database is not being backed up. Let's create a test. All right, let's do it inside stacks. Since we're testing stacks, let's do it inside stacks. Let's create a folder called test, and in there, let's test to make sure our database have our DynamoDB table has backup enabled. We have database.test.ts. And you might not know this. You might not be explicitly setting the backup, but all tables created using SST have the backup turned on, but still worth testing. Cool. Similar to the test on the right, let's start writing a test. Call it. Is it doing ID? Point in time recovery is enabled. Let's write it. Copilot is trying to be really smart. Okay, so when we try to test the resources, AWS CDK has this helper library called assertion. Let's import that. But we'll go over what the library does. Assertions. Note that you don't need to really add AWS CDK lib as dependency. It already comes with SST because this is what SST uses behind the scene as well. And let's just move the imports over. We need test, and note that we don't need the expect function in here because that's something assertion gives us. We'll see that in action. Okay, we also need app stack from resources, and let's import the database stack from code. Okay, all right, let's now write the test. We're going to create an app. We are going to add the stack to the app. This is just basic setup. Now we are going to test against the stack. So we are going to call this. So if you're using functional stacks, this is how you would get the stack object or the struct construct from your functional stack. We expose this top level function called getStack. You pass in the functional stack, it's going to give you the stack object. Okay. And now we're going to use this template method from the assertion library, which is going to give us kind of like CloudFormation template from stack. When you call this, it gives us kind of like a compiled version of the CloudFormation template. It actually does a compile first, and it gave us a template in the format that assertion understands, so that you can call functions on top of template. For example, in our case, we want to check if this DynamoDB table resource has this recovery flag turned on. Right? So we're going to see, does this template has a resource with properties? So the type of resource is a table, and does it have Copilot is really messing me up. Okay, does it have does this AWS DynamoDB table resource have this flag called point in time recovery? Then my note, and in there. Okay, don't ask me why you cannot just set this to true at the top left. It's this weird structure that CloudFormation has. And I'm gonna go over, I have a link where it helps you look up, the CloudFormation definition for each type of resources, which can become very handy when you're writing stack tests. Cool. All right, this is our test. Now let's run npm test. Now we should have 3 tests. 2 are testing your business logic, and 1 testing your stack. Cool. All right, all of them passed. Let me take. There are a couple of useful links I kind of want to show you guys for that I often go to when I write stack tests. I am assuming stack test is a type of test that you guys are at least familiar with. So these links can become very handy. You can always find them through our the testing doc. We have everything we showed is right inside this doc, and if you just go to the testing stacks, you could see these 2 links. One is on the docs. It's a docs for assertion. It provides helper libraries that can be like, hey, how many resources are there? How many AWS DynamoDB table resources in my stack, right? You want to count how many resources you create in the stack. Right, and this is the helper method that we just used to check if an AWS resource has certain properties on them. And has resource properties does like an object like kind of compare. You don't have to list down all the properties. You just have to check if do these properties exist. Or if you want to be super, you could do it has resources. That also checks things like delete retention, right? The retention is set to retain or is it set to destroy on remove. And anyhow, you can go through this doc to see all the different helper libraries that it gives you. Another super useful link that I always go to is this CloudFormation reference that it shows you the template for every single type of AWS resources. Right? For example, if you go to Lambda, something we always use. Let's search on here. Lambda. And right, it shows you each type of Lambda resources. Right? If you look at a function, it shows you what the function looks like in your CloudFormation. Right? If you want to test, does my function have certain tags? Does it have certain timeout memory size? Does it have like a disk attached to it? How many gigabytes of of disk space you're giving it? All those tests. You're gonna see what are the field names for the property names for Lambda function. You can always come here to check. So very useful. But again, I think stack test, I don't think you should have too many of them. These tests, we actually for SST resources, we write a ton of these tests internally. I'll just show you our SST code base. If you guys have used static site, or let's look at function tests. I just look at how many tests we have for these functions, and what we are essentially testing are the things, mostly the things I just went over, where making sure the ID has not changed. When let's say we specify a timeout, we'll give it a number 15. Does it work, right? So say we're testing AWS Lambda function. Does it have a timeout set to 15? If you give us in a different format, 15 seconds, can we also understand that as 15, right? So stack tests are super useful sorry, stack tests are super useful for us in our resources test. But I don't think you guys should have that many of these. But yeah, cool. Cool. I think let's take a pause here and see if there are questions in the chat. Oh, I think no questions so far. All right, I'll keep moving on, and now let me quickly show you guys how we are, what we are doing for this SST load config. So if you're familiar with what we do for config already, this should be very straightforward for you. Like a quick, let's do a quick recap on what config does. Right, in our these. Okay, so in our database, if you remember, we create a config parameter called table name. And in our API, we create a config parameter called API URL. So we have two parameters that our app is using, and we need to make sure that they are available in our test. So let's see what config does. When you create a parameter like this, the value for the parameters, we have a version of them inside the SSM. Right? If you look at SSM, we have /SST, the name of the app, name of the stage, it's a parameter, and it's has the value of API and the name API underscore URL. If you go in there, the value of the URL is stored in here. It's slightly slow. Let me refresh the page. Let's go in there again. Right. So here's the URL. You know why our test is able to figure out the GraphQL endpoint is because of this URL saved in here. And this SST load config, what it's going to do is it needs to tell our config library that, hey, this is the name of the app, this is the stage of the app, and I need to know the name, the value for this API URL. Right, so let's take a look at the code for load config. Okay, load config. First, it does a list parameters, right? It calls into our helper library to list all the parameters. If you look at what list parameters do, it really just calls SSM to get all the parameters that are prefixed with the app and stage. And this wrapper is really just go through all the pages in case you have a lot of parameters, and the API returns 10 at a time. And this wrapper just keep fetching, make sure till the end of the page. So you get all the parameters, you get all the secrets, and we're going to create a set of environment variables called SST underscore app, SST underscore stage, and we're fetching we're putting in all the values for the parameters and secrets also inside this config environment, and we spawn the command, and we spawn the command that's coming after --, right? So we're right, again, we're loading all the parameters and secrets from SSM, we're setting them as environment variables, and we're spawning the command you actually want to run with this environment. So in our test, let's try do a console log of /in. Let's see what's in there. Cool. a lot of stuff that are in here. To make it easy, let's just copy this to a file. All right, look at SST, right? You can see the SST stage is here called Frank. App is called my SST app. The parameter is called table name, and we have SST parameter with the API URL. So now, right? So our tests have all these environments set. So when the test is running our code, when the code is config.table name, config can find everything it needs, right? If you look at what our Lambda function have, see our Lambda function has SST app, SST stage, SST parameter name, so SST parameter table name. We are just we're just setting the exact same set of environment variables so that our config library can seamlessly work, whether if it's running locally, running inside our test, and running inside Lambda environment. So it just works across. So you can think of load config is really mocking the Lambda environments that the function is running in. Cool. I think that's everything for the behind the scenes stuff for load config. Really nothing much to it. I see some questions. Let's see. From Ojan, I have API endpoint that comes in pairs. Command and a query. The function behind a command endpoint publishes an event to a bus. Another function is subscribe this event flow. The endpoint corresponds to a function that performs a query to fetch the results that were stored. I do polling here, and it's just a non-test approach to this architecture. Yeah, I think what Wojang's saying is, in the simplified case where right now, when you call the API to create article, we write to a database directly. How do you test if this API doesn't write to the database directly, but instead it sends an SNS topic, and you have another function that subscribes to this SNS topic, and that function creates this the article creates this article, right? How do you write a test? Because in our API test, by the time this API query returns, the article probably hasn't get created in the database yet. It has to go through SNS topic and then go to get invoked, the subscriber get invoked, and then created. Right. So and Ojan is saying he's using like the polar, right? I think that's the right approach to kind of our recommendation as well. You will do a polling here, and right before this call, I kind of got this code snippet from Dax, and he has been writing a lot of these asynchronous tasks, and he sent me the code he is using. So he wrote a helper library that looks like this. So he created this like eventual helper function where he would periodically ping the check with the database to see, oh, did the article get created? Did the article get created? It runs that test up front, and then if it doesn't exist, it would keep running, keep checking every second until 5-second timeout. And it's probably the same idea as what Ojang you're doing. I think 5 seconds is more than enough for the message to get propagated to SNS and then to the DynamoDB, right? So this is yeah. If anyone has better approaches to test this asynchronous event, definitely let us know. But right now, this is the kind of solution we're sitting on. Uh, I'm going to add a section to the doc with this code with the setup, so I can share with everyone. Was going to do that for the stream, but didn't have time to make that happen. But I'll make sure to add it to the doc. Uncharted asks, if we want to reset our inf, let's say database, how would you do it? Does clearing out the database or seeding the database before the test, does that work? One thing I was going to kind of related to this question is, how do you make sure, how do you run your test so that you don't have to rely on the state of a database. I think it is pretty important that you're not relying on the state of a database as much as possible, so that your tests can run in parallel. They can run in out of order, and you get very reliable test results, right? For example, over here, if what would be like an unreliable test would be if we got like a count of article.count. No, we don't really have this function, but assuming we do, that returns how many functions there are in the system, and you call this API to create a new one, and then you do a count again. It's a new count, and you test, new count to be equal to be the old count plus 1, right? This test, I'm sure no one's writing this up test, but you get the idea, right? You don't want write tests that are relying on the state of the database, because while you're making this request, another test can come in and create a new article, and this test could intermittently fail, which gets super annoying. It's like a really useful scenario for this is, if you guys are building like a B2C application where you have user signups, and often these articles aren't really getting created globally. It's really created within a user. You're creating, this user is creating a new article, and this user's, and you're listing all the article this user's created. In that case, in the database, you probably have like a user ID as one of the columns, and everything is kind of sitting inside that user's partition. And to write that and to test that system, it's very recommended that for every single test, you create a new user, or give it a unique user ID, right? Same thing applies to if your application is not user-based, but it supports multi-tenant, it's structured to support multiple tenants, right? You want to create a new tenant for every single test. And right, it's good to clear out the database, but even if you don't, every test is testing within its own partition, which makes all the tests very isolated from each other. Ash has recommended that. I think using the native AWS event bus makes more sense rather than polling. I believe CloudWatch, CloudTrail give you AWS OmniSigns, and so they work well in test. I'm not quite familiar with the AWS OmniSigns setup, but but something I think, the moment, probably I'm going to talk to Ash after the stream, is something if you find right, like a better approach, we definitely update our doc with that, because something I know Dax and a couple guys in the community, what they do is for every asynchronous event like SNS topic or event bus, they actually add an extra subscriber that stores the event to the database. so that you always have a log that you can almost check or you could test against to see did that even fire. Right, that's a very interesting approach I can take. Some of the other questions I kind of want to go over that kind of popped up in the community. Um, that I kind of want to cover. We want to cover is how to test if an API is authenticated. Um, to be able to test the API is authenticated, right? Again, if every single, ideally you want to make sure every single test is testing against a different user, right? So ideally you want to be able to programmatically create users, generate these tokens, however is authenticated, right? In the majority of the case where you should be able to generate like a JWT token, create a new user, generate a new JWT token for the new user, and kind of pass that in through your through your API call. And so it's very important that you kind of like pick like auth provider that allows you to do that. That's kind of one of the reasons we find a bit hard to test against if you're using Cognito, where I don't think it lets you to generate users and authorize them on the fly. But correct me if I'm wrong, but you kind of get the idea, right? You want to every single test should use a different user, and you should be able to generate. You should be able to authenticate and authorize the API request as a different user for each different test. Seth is saying configuring DynamoDB as an event bridge target while testing is another cool way to test your event-driven application. Yeah, definitely. Yeah, I think Seth is suggesting a similar as just having a DynamoDB as a target for your or subscriber as for your events, so that you have this again have a log where you could use as a source of truth to check and verify anything that happens asynchronously should have kind of footprint in there. Cool. I think that's everything I have for today. Hopefully I kind of answered most of the questions around testing. Right, very intentionally, we didn't want to use the wording of unit testing, integration testing, because everybody tend to have like a slightly different definition of what those tests are. So that's why for today's topic, we really want to just look at your SST app, right? If you kind of follow the domain-driven pattern, it's very clear there is you want to test your domain functions, you want to test your API, and you want to test your stack code. I think that covers most of the tests you might want to run for your SST apps. And that sums it up. All right, thanks everyone for joining. I will post this link. I remember I'll do two things. I will post this video on YouTube and have the link posted, shared to you guys, and also update the doc to add a section of how to run asynchronous tests. Thanks everyone.